How's that, sports fans? Well, it's time to see how good a job this did. Well, it looks pretty nice. Unlike a regular lathe that has a tailstock where the tailstock is always fixed so it's in the center, this tool carousel can move back and forth. The height is always fixed because of the height of these tool blocks, but lateral in and out is not. So I need to make sure that the center of this tool holder is in the center of this collet. Once I'm there, there is a stop over here that you can run this up against that stop, and then I know I'm in the center. What I'm going to do is get another collet. Ever show you my collet? This is the door. Down on the bottom I've got a lot of extra collets, and that's where all the vices are stored. I've got collets for all different things, specialties. Round, square, hexagon shape. I think the one I want's up in here somewhere. All right, ready to drop. Probably hot as all get out, so if I do this quick, I can let it down without hurting. Hi folks, before we get started, I just wanted to say a couple things. Thank you. I'm almost to 10,000 viewers. I never thought that would happen. It's taken a while though, but I'm getting there. Tonight I'm going to use Bob, my chucker lathe, to recreate a gib screw for a 1954 Axelson lathe. Now, I'm rebuilding one out there, and I lost this for some reason. Well, Don has the same lathe, and I went over there and borrowed his, and I tried to make a few improvements on his. Now, this one over here, oh crap, I'm sorry, I was using my hands again. Your guy's going to get mad. Let me get my shoes off. This is the, y'all see those? Look at the screw slots. See how that's splayed open? Well, it's much bigger than it needs to be. This one here is the one I just finished, and I made it to fit a screwdriver pretty tightly so that it'll have more strength down here in the bottom part. It won't bend so much. Somebody cranked on this with a screwdriver without loosening the gib screws. Anyway, this is all done. This is how I did it on Bob. One thing. You're going to see me trying all different kinds of things to figure out why it's chattering and such. Well, I kind of showed you all the different things that you could do to figure out what's going on in this video. Wouldn't normally do that, but sometimes it's nice to see how other people work. So, thanks for watching, and here we go. This is an adjustment screw for the crossfeed on Don's 16-inch Axelson. I lost the one for the 16-inch over here. I was putting it together and couldn't find it. So I begged this one. He went and took it out this morning, and he wanted me to make it and bring it right back to him so I don't lose the dang thing. I just admit I did lose the first one, but I'm not going to lose this one. I'm going to stick it in my pocket. Most of the exact dimensions, and I'm going to show you what I usually do on parts like this. You know, I could go over there to the bin, sit there and measure a few things and just whip it out. But I'm going to make 3 of these. I think the same one fits in my 20, but I want to keep a little diagram. Now usually I use my CAD program over here and draw it. This is the cross section of the rails. I'm getting ready to finish grinding those. I'm sorry it's taking so long, just things get in the way. So I kind of wanted to show you what I usually do. You just need a piece of paper and a pencil. Then you can make a decent drawing. A lot faster than I can do it on that. First off, just draw out your basic shape. Then draw some threads. And then finish up your drawing. This goes out here. Then it's got a little slot through there. So now I got a drawing down here. Just need to dimension it and we'll be through. First off, you notice I got a thread. Well, in the old days, you had little thread checkers, but somebody invented these. I love these. They've got a male on one side and a female on the other. They're cheap off of eBay or Amazon. They're marked with what? This one is metric. This one is SAE. And basically, take my screw and set in here and find one that it fits into. Fit in there. There we go. That screws all the way in. That's pretty good. So that tells me it's a 5/16 by 18 thread. So that's one part of the equation. Now, like I say, they make these things. Used to be this is as big as you could buy. Look what I bought. It's a mother of all thread gauges. Now I'm going to modify this one a little bit because I don't work in metric very much, and this has got metric and SAE on the same chain. The reason I bought this was I use bigger threads a lot of the times, and this one checks them all. Up to 1 inch by 12. It's got 1 inch by 8 on it. 3/4 16, 3/4 10. And then the black ones, they anodize those a different color. Those are all metric. Well, this is hard to handle. I'm just going to cut this and put another loop on the back end of it. This one's got little wing screw and a collet, and you can just tighten that up. Take it off if you need it. Whereas these, they just made a loop and then they crimped that wire crimp on it. They both do the same thing, just this one's a big one. I had to look hard to find one, but I found one. You can too. Get these out of our way. Next thing I need to know, because I'm going to do it on the lathe, I want to know how big this outer diameter is. There is 0.30. For this one, $300,000. Then I want to know how long it is. So you can take your calipers and just stick it there and run it down there. 1 inch, 207 thousandths. We're going to make this 1 inch, 207. What the heck? Then I need to know the diameter of this part. 620 thousandths. 620. Need to know how thick that is. 0.158. Then I need to know the diameter of that little screw head, 268. And I need to know its length, 268. So there we go. In a couple minutes, I have us a diagram that tells me everything I need to know about that. I'll throw this in with my little papers. This is an Axelson 16-inch Gibbs screw. Well, continuing on from drawing out the little drawing I showed you as I was starting, it's time to make it. What we're making, just to recap, is a Gibb adjustment screw for a 16-inch Axelson. Now, Axelsons, if you're not familiar with them, are probably arguably one of the finest machine tool lathes ever built. They were built over in Los Angeles, and the last one was built in 1954. Another well-known company, who shall not be named around here, bought them out. Said everything's going to continue on, and then 1 year later they shut them down. Why? Because they were innovating. They were making things that nobody else had. Seems the way of a lot of companies. Think Autodesk and generic CAD. I'm still pissed about generic CAD from back in the late 80s. Generic CAD was a really decent upstart company that made a really nice drafting program I was using back there. Got bought out by Autodesk. Everything's going to be fine. They shut them down a year later. So I'll never buy Autodesk. Anyway, we're going to use Bob to make this little screw here. Once again, this is what we're making. Now, about 90% of doing machine work is figuring out how to do it. You know, there's a screw, but how did they make this screw, and what should you do to make it? There's 10, 15 different ways I could think of to make this. So you use the tools that you have. Right now I'm down a lathe, the 10EE, it's the only one I have that is small that I haven't sold off, that could thread this, single point thread this. I could do it on the Axelson, but it's just big, and I like Bob. Now, Bob has a threader. This part up here is an automatic threader, and I could set it up and spend the time, and it works really nice. This comes down and automatically, depending on how many times you set it to take a cut, will, like say 10 times. It'll lay down and cut that thread 10 times to depth and then stop. The way it does it, let me get some parts here for you. It uses these little threaded sleeves. Can you see that? Now these sleeves fit on the spindle, and then there's this follower that's also threaded. I don't think it wants to show you. It's really fine when this one is. This one is 36 threads per inch. Anyway, it comes down and lands on this and follows it. And that's how you set it up. I've got a whole bunch of them for different threads. Anyway, I just got to do 2 of them, and it'd take me 2 hours to get that all set up, so I'm going to do it a different way. There it is. This is a 5/16 by 18 thread. Now, making this part, you know, you could start and make all of this and this and this, then thread it later and all this. But there's a critical part in here that gives me pause and made me think of how I wanted to do this. This long 1.25 inch, I guess it is, thread has got a weak spot where it's relieved right there. Now, if I put a lot of effort, like single pointing it, if I didn't put a center down here, it'd probably bend a little bit as I was cutting, thus setting up stresses in that corner right there and pop right off. I can't single point it on this machine, so what I'm going to use is a die, and this is in a holder that is hollow. It'll go all the way through here, so I can start this on there and cut it. All I have to do is make the outer dimension, lube it up real good, and stick it in. Sound familiar? Anyway, because of the torque and the rotational force of this cutting, I could twist it off, and I might still do that. So in an effort to combat that, I'm going to first turn this part on a piece of stock and thread it, and then cut the rest of it. There's no sense in making it all if we're going to turn it and break it off. So we'll see how that goes. The other part is over here on the end. Come on. Now there's how it looks right now. I thought about redesigning that piece to make it bigger. You might have too many things and not enough hands. You see how that's kind of, come on, focus. See how that's kind of splayed out there? It's a big, big slot too. I think somebody put a big old screwdriver in there and started turning on it without unlocking the gib lock on it. Most gibs have some set screws in it that lock it in place after you adjust it. So obviously somebody got real rough with it. I thought about making that bigger, but I don't have the room. It won't fit in there. Then I thought, well, why don't I just make the slot smaller? It doesn't need to be that big. You don't put a lot of force on this. And if I make it a smaller slot, the shoulders get wider and stronger. Now, most screwdrivers that you buy are tapered. But if you get a set of gunsmith screwdrivers, they're parallel size. So they would fit into that deep slot all the way without spreading it open. So what I'm going to do is make this a little bit smaller so that it'll give me bigger shoulders and more or less likely to splay open like that. Don asked me how I was going to do it. Slitting saw, slitting saw. I said, well, I only got to make 2 of these. By the time I get out of an arbor and set it up on the mill with a slitting saw, I can take a hacksaw with a fine blade on it and cut that slot, and then take a file and run through there and clean it up and be done with them. So he said, but that's not the machinist. That's not a machinist type way to do things. Who cares if it gives me the same dead-gum results and it's faster? Make more money that way. Of course, I lose money. Don't make it. Okay. I got to change a few things. Now on Bob, I've taken off the chuck that was on there. And I put the thread protector back on it. And now it's set up to use the 5C collets. over here I have a chuck so that I can chuck this up. But on this lathe, unlike a regular lathe that has a tailstock where the tailstock is always fixed so it's in the center, this tool carousel can move back and forth. The height is always fixed because of the height of these tool blocks, but lateral in and out is not. So I need to make sure that the center of this tool holder is in the center of this collet. Once I'm there, there is a stop over here that you can run this up against that stop, and then I know I'm in the center. So I need to get this going so I know where it is. And like everything else, there's lots of different ways to do it. I kind of like using a bar that will fit into that tool holder, put the bar in here so that I can just move this until it fits perfectly, then lock it all down. Fortunately, I don't have any precision I think it's 5/8. Yeah, I think this is 5/8. Bars or drill rod that size. So what I did was I snuck into my toolbox and I got a boring bar that's that size. And what I'm going to do is get another collet. Ever show you my collet? This is the door. Down on the bottom I've got a lot of extra collets, and that's where all the vices are stored. I got collets for all different things, specialties, round, square, hexagon shape. I think the one I want's up in here somewhere. Let's see. Where'd you go? That's not you. That's not you. There it is. Right there. Keeps them out of the way. I'm going to get y'all a little bit closer. How's that? Can you see? Didn't mean to make you dizzy. Now, the problem I have is this collet, or this bar, has a tool on the end, and I need to stick this end into the tool holder. So what I'm going to do is just put this in backwards like that. So now I've got a nice bar sticking out, and then I'll install this collet. Hope you're focusing. See what I've done. Now I'm going over to here. I'm going to back off a little bit. Now, for those of you that don't know much about 5C collets, on every collet there's a milled recess here, a keyway or a pinway, and when you stick it in your spindle, you feel it around till you hit that keyway before you put it in. You don't sit there and bang it on in if it's tight. You ease it in. Same thing on a Bridgeport. Those R8 collets, they have a milled spot and a pin inside that spindle. And half the ones I work on, the pins already broke out because somebody didn't take the time to do it right. Anyway, back here on this other side of see how that went in real nice? We'll let that stick out. And I'm going to start pulling the collet in with the drawbar. Check, see how hard it is. That's a little bit too much. A little too much. No block on me. Why won't you lock collet? Now we're close enough. Too much. Too little. Just right. All right. Now I'm going to set up my You see what I'm doing over here? What I'm doing is I'm turning this drawbar, goes all the way through, and screws in the back of that collet. That's what the collet has on the back. And I've adjusted it. If you can see, when I move this handle here, that collet gets pulled in. And what I want is this to cam over and lock, just like that. If it's too loose, it won't do that. If it's too hard, too far in, it won't do that. Now I'm going to sit here and unlock it, and I'm going to lock everything in. So now everything is all put together and everything will turn at the same time. That'll lock. I've got my bar sticking out. I want to ride back up here for a while. I know this camera will go to the front screen. That's the reason I brought it. There we go. Maybe you can see what I'm doing. How about that? Dizzy, don't fall down. So what I want to do is I want to move my tool holder in position. I'm going to move it all the way back against that stop over there. Then we're going to advance it, and I want that tool holder to just go in there. And if you notice, it's not doing it. It's too far in, it looks like. So I'm going to pull it out a little bit and keep trying it till it just slips in there. See how that just slips in there? That tells me that's right on that center point. Everything's aligned between the tool holder and the collet. Now, if you go back over here, I can do it two ways. I can take and unload, I can take and unbolt this tool holder and then let it sit there and move it against the stop, or I can just move it against the stop back over here, which is probably going to be the easiest thing to do. Got to unlock it first. I'm just going to run that pin up against there. I could also just take and do that bolt on top, but this is more of an accurate alignment when you get real close. Is that up tight against it? Need to move it out a little bit more. Just a little bit more. I think will be perfect. Run it out here, run it back up to the stop, and see how it does. Oh, that's sweet. No lube necessary. Lock this back down. And that's all there is to it. Now I've got a perfectly lined up tool holder on axis. Now that I'm lined up here, I can get rid of this. So we're going back over here, unlock that, unlock the collet, and start turning the inner race or tool drawbar. And we're done. Don't need this one anymore. Now to make this screw, I thought a lot about material selection. There's no pressure on this thing, and I'm afraid if I made it out of stainless steel it would gall too bad. So I just went looking around for some stuff I had laying around, and I found some water hardening tool steel around a bit that we're going to use. That'd be plenty for this. Now, another collet. Had enough space to get in there. Find that slot. There you go. And we'll turn the drawbar again. Too much. It's a little bit light. There we go. Lock together. Everything should be okay. I'm going to slide that in. I don't want a lot sticking out. Now, the reason I put that tool holder on center was so I could put this chuck in it. And that's where it needs to go now. Be back. I need to stone that a little. Now, the other day I was looking at all my stones and they'd gotten to be an oily mess. So I figured, let's clean them. Here's a little video on doing that while I hone this. Turned out pretty doggone good, I thought. Well, another use for your sonic cleaners. This one I got sitting up here getting ready to clean all my stones. They get dirty after a while. And this one's been running. Well, let me pull it out a little bit. That's how that stone looks after about 38 minutes. It was that color. Needs a little bit more. I'm gonna dump the rest of these in here. I'd have to pour a little more fluid to cover them in there. I'm using a little bit of Zep. That works really good. Tried dishwashing lotion, or liquid, but it didn't do much good. We'll need a little more water here. The scum coming off of it. Little cleaners work great for everything. Put the lid on it. Got the heater going. It's up to 43 Celsius. 75 is pretty good. Then I usually let it go for a little bit more than. I don't need 60. About 45 minutes. Well, it's time to see what's happened. this off. Well, it's time to see how good a job this did. Well, it looks pretty nice compared to what they were. Oh yeah, that purple power did a pretty nice job on the stones. I love this thing. We'll dry them off. What you guys think about that? It's an easy way to clean stones. Tried dishwashing detergent and that didn't do very good, so got out the old purple power. And a word of caution on that purple power, where you're doing what I did, get the heck out of there. Don't stand around and breathe that stuff. I opened up the main shop doors and got out. Now I've got the chuck installed. I can put this in there. Now I'm not going to tighten it up real tight. There's one problem with doing this way. When I do it on a manual lathe that has a tailstock, the tailstock is free to slide. If you unlock it, and as it's threading in, this will pull it. Well, this doesn't pull very well. So I'm going to have to be very gently and see if I can feed it in at the same time. Otherwise, it could be a problem. And to overcome the forces, if it gets in the bind, I'm going to have this where it'll slip a little bit if needed. So that'll keep us out of trouble. Anyway, we don't need that right now, so we're going to whip it out of the way. We'll come back here where I have a tool bit set up, and we'll face this off. We're going to take and make this first part of the screw. It's 1.207 inches long. Need to put a chamfer on the end of it and cut a little relief there. I'm not going to cut the relief just now. I'm going to leave it and thread it with that die, and then I'll cut it if need to. You don't really need it. It's just there for when you're, single pointing, but might make it stronger not to even have it. Now, old Bob's a three-phase machine. I live out in the country with my shop beside my house. Got a 40 by 60 shop here, and I'm about $32,000 away from true three-phase electricity, so I have to make my own. That's why I had to go turn on the 10 horsepower rotary phase converter. I use it for all my little machines, and then the 20 horsepower rotary phase converter does the big 20-inch Axelson and the planer. Bob, you pull to start, and I love this machine setup. It's got a forward and a reverse, and you don't have to let it calm down to go. It will go from one to the other immediately. It's also got electronic speed control up here. All the bearings are self-lubricated. You never have to put any oil in the headstock. This is 3 speeds, first, second, third, and up here you adjust those speeds with this rheostat. Speed 3 will go from 1050 to 3000 RPMs. Guess you could see that. Speed 1 and 2 are on the same rheostat. It'll go from down to 125 to 420 on one, and then 375 to 1250 on 2. Well, we're not going to need that. We're going to have to go as slow as we can for threading. And let's just see where we're going to be. Let's go about 1550 on speed 3. 1 to 4. Just go back and take it off and see. Do a final pass at about a couple thou. Now that took away all the chatter, and for threading that's an acceptable finish, but let's see what we can do. Well, first we better see if we've gone too far. I need to have that 0.300, it's 0.53. So I got 53 thousandths to play with here. What I'm going to do is leave it at that RPM and increase my rate of travel and see if that gives us a better finish with no chatter. Let's go 20 thousandths on that. That's pretty much perfect for what you see in here. It's pretty much perfect for what I want to do. Let's make sure it's the right length. Let's see, that is right at 1 inch. And we need to have 1.2. So I need to come in here and work that and get that down some. So we're going to just come out like this, go over here, and then go forward. You'll need a little more. Over here and set a 0. There's our 0. That's on 160. Now we'll see how far we got to go. I have 32 thousandths to take off, and frankly, I'm going to take it all. There's 10, 20, 32. Y'all ready? Be at 192 on the dial. I think we could go a little bit slower and get a little nicer finish. .307, 303. Let's take that 3 off. 192, 1, 2, 3. Of course, this is hot metal and it's probably expanded, but yeah, normally I'd let it sit for a while, but this is just going to be for a Fred. And I don't think that 3,000 is going to matter much in this case. Now we need a chamfer so we can start. This is hard doing with you guys watching. I'm not over here where I normally am. That'll work fine. Now for the moment of truth. See if this will work. Otherwise, I'm going to have to sit here and hand tap this thing. Move my chuck with the die in it. Rolling it into the stop. There it is. These two things should be lined up now. Now I need to put some good cutting fluid on that. Went and got some of my favorite tapping cutting oil. This is Trim Tap Heavy. It is really sticky and works like magic. This stuff is so good. I found out about it a long time ago from my high school shop teacher, and I were pretty good friends for years, going fishing and working on projects together. During the summer, he'd come work for me. Well, one day he went to a machine convention, and he came back with a bottle of Trim Tap Heavy. And I was having problems doing some tapping, and he says, "Here, try this." And he handed me that bottle. Man, it was a miracle fluid. I'm ashamed to say that I swiped that bottle from him. Then later on I bought a big gallon and poured him up a bigger bottle and gave it to him. But I swiped it. He said, "I can't find it." And I didn't know. Of course, now he's up in the big machine shop in the sky, and sorry, Joe, but the devil made me do it. It's that good. This is like cocaine for machinists. All right, I'm going to slather it on here. A little bit will do it. In fact, I've got a gallon of this stuff that I've been using maybe 3 years now. We're going to turn this machine down to speed 1, and we're going to go slow. Real slow. Let's go slower than that. That's its slowest setting. Now this may be a train wreck. Hopefully it's not. Hopefully I've got enough stuff in here that I'm pretty happy with that. Now what I'm going to do is go in here now and relieve that part. And the cool part about this machine is once I've set up these tools, I can do 100 of them. I'll tell Don he'll want 100. Did I mention this is all Don's fault today? All right. We're going to need another little bit to go into that recess, so let me go check out my old stockpile over here. Let's see what we got that will work. Let's get into this section where we got some, that's the wrong side. That's the wrong side. That's the wrong side. what you do is you get close to your headstock, and makes it hard to cut into. That one would work. That's a little bitty tiny one. I'd have to shim it up. So let's see if well, that's for putting tiny O-rings in. Grooves, don't mess that up. There's one the wrong side, wrong side, wrong side. Tell me I got a grind one. I think I can make that one work. Well, here, wait. There's one that'll work just fine. Let's get it in there. Well, I don't want to mess that one up. This one we find is kind of long, so let's put another tool holder on that we can back into the drawers. Find another small tool holder. I even have one already set up. Well, yeah, that one will work better. We'll just use that one. I think I can get in there. Let me check it. I can't. Y'all aren't even looking. I'm over here. Now you're cattywampus. Y'all been drinking? Hopefully none of that light beer. This is getting in my way when I try to use the smaller tool. So we're just going to take it off, put it back here in the drawer. And we can put this one anywhere we want to, and it will be okay. Always check your clearances on these things. It's nice having 8 tools, but sometimes they stick out a little bit. Okay, let's go to speed, say 3. Forward.